Hi, PreCalculus. Welcome back. Here's 5.2, example number 5. So we are verifying trigonometric identities by working each side separately. So sometimes when we're working a problem, if we get stuck, it might help us to work on the other side and come to a meeting point to help us to figure out how to end it. So let's see what that would look like. I'm going to start this one on the left-hand side. I've got a fraction with the 1 plus secant underneath it, so I'm going to start off by multiplying by the conjugate. So 1 minus, I'll take this line, Miss Harris, 1 minus, 1 minus secant theta over 1 minus secant theta. When I do this, I get tan squared theta times 1 minus secant theta. On the bottom, I've got 1 plus secant theta times 1 minus secant theta. Those are conjugates. So 1 times 1 is 1. My middle terms are going to cancel. Secant times negative secant is negative secant squared theta. Now be careful because you're going to see that tangent squared theta. You're going to be like, oh, I'm just going to plop in tangent squared theta. But be careful. This is our identity that has both tangent and secant in it. This time it's not secant squared minus 1, it's 1 minus secant squared. So I'm going to move the secant squared this way and make it 1 minus secant squared. But that means I need to move tangent squared over here. So 1 minus secant squared theta is negative tangent squared theta. So I've got tangent squared theta times 1 minus secant theta over negative tangent squared theta. Now my tangent squareds cancel out, and I've got minus from the bottom, don't forget you got that minus sign, and then 1 minus secant theta. I'm going to distribute that. Negative times 1 is negative 1. Negative times negative secant is positive secant, so I'm going to flip their position. All right, but I'm trying to get to 1 minus cosine theta over cosine theta. I don't know really what to do with this. I guess, seeing that cosine theta in there, I'd probably say this is 1 over cosine theta. You might be able to see from here how to get there, but if not, if you get stuck, especially if you're stuck here and you're not sure what to do, start at this end and see if you can figure out how they meet. So here's 1 minus cosine theta over cosine theta. If I was working this side, I'd split it up into 2 fractions, 1 over cosine theta minus cosine theta over cosine theta. And so this is secant theta minus 1. That's where we're at here. So really, what I want to do to this 1 is turn it into a cosine theta over cosine theta. Now, I can't work both sides at the same time and be like, okay, well, this side's equal to secant minus 1, and this one is 2, so that works. We want to go from start all the way to the finish, all on one side. All right, now that I've got these guys both converted, we can make it back up to our final step. So this would be 1 minus cosine theta over cosine theta. So you have the light turn, and that's what we're trying to get to. So I can say this part here. So the whole point of these problems, example number 5, is to say sometimes if you get stuck, try seeing if you could back out the other side a little bit to figure out, and once you get here, then you want to write the steps backwards to get your proof finished. All right, you try. It doesn't really require a lot of backwards engineering. It's really just a factoring problem. Either side you start on, either over here where you're factoring out tangent squared, or over here you're factoring out secant squared. I'm going to work on the left-hand side. And so if I take it out, secant squared, I've got 2 more secant squareds in here. Here I've got minus 1. We know from our trig identities that tangent squared x minus 1, plus 1 is secant squared x. So secant squared x minus 1 would be tangent squared x. This guy is tangent squared x. And before we start getting all fancy, what is secant squared x? Well, this is secant squared x, so that's tangent squared x plus 1. And since I'm trying to get to something with tangents in it, I could go and flip it, make things sines and cosines, but if you look to where you're going, here I see I'm going to be in tangents. If I could find a way to represent this not as cosines, but as tangents, then I could be closer to my end game. So my end game is tan squared times tan squared is tan to the fourth x. Tan squared times 1 is tan squared x. And that's what we were trying to get to. So we are there. And this is the end of example 5. Next video, I'll get you example number 6 and we'll be done.